Hello ladies and gentlemen, welcome to my video. This is today's question. It's actually not difficult at all. We just have to manage the hyperbolic sine function, and then it can be solved using substitution as well as integration by parts. First, we look at the hyperbolic sine function, which is the sine h. We know that sine ht is defined as e power t minus e power negative t divided by 2. Therefore, sine h natural log x and then divided by 2 is equals to e power natural log x and then divided by 2 minus e power negative natural log x and then divided by 2, the whole thing divided by 2. Meanwhile, we know e power natural log t is equals to t because the e and the natural logs are cancelling each other. Therefore, sine h for the natural log x and then divided by 2 is equals to x power 1 over 2 minus x power negative 1 over 2 and then divide by 2. Put this back to the original q, and then we obtain the new q, now without the sine h function. Next, substitution. Define W equals to x power 1 over 2. Therefore, x equals to W power 2. dx equals to 2W dW. As for the integration bound, when x equals to 1, W equals to 1. When x equals to 0, W equals to 0. From here, we obtain Q equals to 1 over 2 integral 0 to 1 W minus W power negative 1 and then multiply natural log W square plus 1 divided by W square and then multiply 2W dW. Further simplify give us Q equals to integral 0 to 1 minus W power negative 2 and then multiply natural log W power 2 plus 1 dW. Next step is integration by parts. We can say Q equals to integral 0 to 1 U multiply dV. U is defined as natural log W power 2 plus 1. Therefore, du equals to 2W divided by W square plus 1 and then multiply dW. Meanwhile, dV over dW equals to 1 minus W power negative 2, which means V equals to W plus 1 over W. From the definition of Q just now, we can further rewrite as U multiply V and then minus integral V du. We have all the terms we need, which is equals to W plus 1 over W and then multiply natural log W power 2 plus 1 for W equals to 0 and 1. And then minus integral 0 to 1 W plus 1 over W multiply 2W divided by W square plus 1 and then dW. Here we can say that Q is equals to L minus J, where L is the first part of the equation while the J is the second part of the equations. Now we focus on L, which is equals to L1 minus L0. L1 is quite easy. We can just put W equals to 1 to the equation for L, which is equals to 1 plus 1 over 1 multiply natural log 1 square plus 1, of course equals to 2 natural log 2. Meanwhile, L0 equals to limits W tends to 0, W plus 1 over W and then multiply natural log W square plus 1. Further rewrite give us limit W tends to 0, W square plus 1 and then multiply natural log W square plus 1 divided by W, which is equal to 0 divided by 0. Apply L'Hopital rules. Give us limits W tends to 0, 2W multiply natural log W square plus 1 plus 2W divided by W square plus 1 and then the whole thing multiply W square plus 1 and then divide by 1, which is equals to limits W tends to 0, 2W natural log W square plus 1 plus 2W. Put in W equals to 0, give us exactly equals to 0, which means L is equals to 2 natural log 2. The second part of Q is J. Focus on J now. This is the J. If we rewrite W plus 1 over W become W squared plus 1 and then divide by W, it will cancel with the second part of the integrand, which means J is simply equals to integral 0 to 1 2 dW, which is equals to 2. We also know that L equals to 2 natural log 2 and then Q equals to L minus J. That brings us to the conclusion of this video. The final answer of this question is 2 natural log 2 minus 2, which is approximately equals to negative 0.6137. Thank you for watching my video until the end. Please continue support my channel, subscribe, give a like and share my video with others. See you soon for my next video. Bye bye.